Um, so let's get started. We're going to learn a little bit about this class just by my little poll I took before, um, and also get a just kind of a fun look at different ways to represent the data. So first of all, let's look at what, in your judgment, you guys think was your skill level at the start of this. And it's definitely on the lower end, which is what we hope for in this class because we want to, it's somewhat intro level. Um, it's I'm the main reason I collect this one is I want to see what it's like afterwards. So we'll do another poll at the end and see what the change is. Um, Obviously, we hope to see everything going over here, but or at least into like the 2, 3, 4 range. Um, but you never know because I tend to find that after I take a class, I feel like I understand the subject less than when I took the class in the first place because you start to get the depth of it, and yeah, but it's should be an interesting thing to look at. Um, the other thing we have here is how many ML classes have you guys taken? Mostly, we've had no's, which is just fine. Prerequisite for this class is just systems programming 252. So, and that's just so that we know that you can complete a big project with some skill. So we have that. We had a fair number of people though that took 373, and I think just one or two people. I think two people that took 471 as well. Um, Remind me, which is 471? What are they? What's that one? Is that search engines?
It's intro to AI.
Oh, is that intro AI? Yeah. I took that in New Zealand, so that's probably why I don't remember Purdue's course number for that.
The search for engine is 473, I believe.
47. Okay. Yeah. Um, but that's good. So if you took the 471, you're definitely this is going to be a fairly there we'll have challenges for you. There's a lot of added stuff that you can do and extra credit opportunities, but this shouldn't be too much of a struggle for you. But at the same time, if you just haven't taken any ML classes at all, um, it might take some work, but I think you shouldn't have real trouble with it. This isn't meant to be a super hardcore class as much as it's you get what you put in. Python experience. So this one was interesting. We had a 50-50 split on whether you've done Python or not. If you haven't done any Python before, it is super, super easy to learn, especially if you know C already. In fact, Sri and Anthony, if you're here, I don't know if Anthony's here, but I saw Sri's here. Uh, you both started this when you guys first took this class way back when that was your first Python experience, correct?
Yeah, it was. I don't think I knew anything about Python before this. I may have known just a bit, like used it once or twice, but I basically knew nothing.
And how difficult did you think it was to learn?
Not it wasn't difficult at all. I mean, it's mostly just syntax and like, oh, this is possible, but like you can always just start by trying to do the exact same that you would do in C, and then every now and then you'll find out like there's a syntactically like easier way to do it. But it's pretty easy to pick up. With a lot of the skeleton code just helps with syntax. So
Yeah, yeah. The big thing to get used to is that there aren't any types, which is there are, but you can't see them. You know, they're all hidden. Um, anyways, uh, I also took TA experience, and this is a good description of how, or a demonstration of how data can fool you a little bit. Over here, we can see that it looks like 50% of people took no TA classes and 50% did some class. But that's not actually true. In this case, I changed the data up. It's the same numbers that you guys put in, but this time I was going none versus some. And in fact, most of you haven't done any TAing before, which again is fine. I just wanted to see. Um, But the reason that this pie chart is a bit deceptive over here is because some people have TA'd for multiple classes. In fact, I think one of you TA'd for like 3 different classes throughout, which is pretty cool. That's a lot of coverage. Most of you are juniors. Some of you are seniors. That makes sense because we only offer this to people who've taken 252, and generally that happens at the end of your sophomore year. And finally, favorite sci-fi movie. This is a fun one. I definitely noticed, so Star Wars definitely has a little bit of real estate over here, but less than I expected. Maze Runner, there was a lot of people who were into that. The Martian, a lot of these kind of newer ones too. Interstellar got a lot. I like that movie too, so that makes sense. And that's it for that little quick slide. So that was just a fun little start for this. Now we can get into the real meat of everything. So this course is taught by me and Gustavo. I'll mostly be doing the lecturing. If you want to ask Gustavo a question, you can email him at his email there. Go to his office. I assume the office hours are going to be. Gustavo, you're not doing office hours this semester, right?
Yeah, I'm doing office hours. They are going to be shared with 252. Yeah, if you want to go to the website of 252, I will be there. Before we continue, everybody has submitted the forms and the registration has proceeded. Is that right? Yeah. Okay. If you have any problems with the registration, just send me the form. I will sign and I will send it back to you. Okay. Okay. Go back to you, Max.
Awesome. All right. So, here's me in my nice professional picture. Master student, hopefully soon to be PhD student. We're working on that. Working on machine learning and AI. You can email me right here, and I don't have an office, but that's fine because offices are where COVID is, so that's good. So class is going to meet once a week. Attendance is optional. Highly encouraged, though. There will be opportunities for extra credit during class. So basically what's going to happen is I will be asking questions in class or asking people to explain stuff. And you can choose to answer them. And if you do, I will give you a small amount of extra credit. That's something I learned from Professor Walid. I think he was a databases guy. He used to do he used to give you half point every time you answer a question. So I'm going to do something like that. But yeah, still it's all extra credit. It won't affect your grade if you don't come because of time zones or whatever. But I suggest you be here, and I will reward you as such. This course will have 4-ish projects besides the group project. We'll see. It might end up just being 3 projects, but most likely we're going to have the new 4th one in on time. We do have 1 group project at the end, and that's going to take up like a full month almost, maybe more. And that's kind of a cool open-ended project to work on. We're also going to have 1 homework assignment right at the beginning. That will be very, very easy, so don't worry about it too much, but just make sure it gets done. No midterm or final, but there will be a short quiz about the lecture material each week. That's already, the first 2 are posted already. And you can get started on those whenever. Generally, so I think the due date for those is on paper going to be the next week over. So the lecture quiz for this week is going to be due right before class on next week. But if you turn it in like 1 week or late or something, that's not a big deal. If you're turning them all in at the end of the semester, I'm going to be a little bit more annoyed. But definitely try to get those in a timely way. Turn-in instructions will be included on everything. It's mostly just email with a specific submission header. All coursework is going to be in Python 3 as well as a few extra libraries. At some point, probably next week, I'm going to set up an optional thing where you guys can come in and I'll help you set up your environments if you're having trouble with it. We're mostly going to be using TensorFlow, but we'll get to that later. If you don't know Python, though, this is the one thing you should definitely start to do right away, is just learn it real quick. Learn the very basics of it. You don't need to be a master at it or anything. Just understand how to, create basic objects, functions, all that nonsense. Yeah, it's quite intuitive. I think the intro email to this, I also sent you guys a number of tutorials to choose from as well, so that might help. This is the approximate grading scheme for the class. That homework I talked about is going to be 5%. The quizzes will be 10%. The labs will be this many percent. Let's see, 30, 40, 50, 60. Yeah, 60%. And then 25 for the final project. So let's talk about the scope of the course a little. This course is, the way to think about this is an introduction to neural networks as applied to the field of image processing and computer vision. We definitely are more on the neural network side than the image processing side. And that's mostly on purpose. It's just because it's supposed to be a class that is the core of its neural networks, but we're viewing them through this lens of image processing. This is not a general course on neural networks, though, at the same time. Those exist out there. I don't think there are all that many at Purdue on the undergraduate level, but they have them. Machine learning, we definitely have that in 373. Computer vision, that's its own separate field. We will cover some theory. Most of it's going to be about application. We are going to get into how neural networks actually work, but we're not going to be diving super deep into the math of it or anything. Most importantly, though, and one of the biggest reasons I wanted to make this class way back when, was we'll be building some cool sci-fi stuff. And that's the real crux of it. We're going to build some really cool stuff with neural nets that can do things that you wouldn't even be able to really expect that computers could do to some degree. So, what is neural image processing as a field? Well, there's all these different tasks. It's just generally any task that involves processing an image with a neural network. This can include classification, caption generation. We'll get into all these and what they mean a little later. I don't want to jump ahead too much. I will say that we cover more in lecture than we do in the projects. Hopefully we'll be doing one on caption generation too, but otherwise it's mostly going to be classification, generation, and style transfer. So let's look at some examples here of different tasks we might have. In this case, we have this is a classifier from this website down there. It's got this picture of me. Strangely enough, this is at my old apartment. I just have the same couch and the same pirate flag and the same setup. So if it looks exactly the same as it is now, it's because it basically is. But anyways, what this classifier has done is it's got these different categories here, and it's decided that the most likely ones, probabilistically, are that it's a string instrument, a musical instrument, a guitar, or acoustic guitar. And all of those are correct, except this one's kind of not correct because it's a hybrid acoustic, non-acoustic, but that's fine. It's close enough. So this is our caption one. This is from another website. Though this one, I don't think it's just directly applying a neural network, and you can see why, just because it's got this structure that it's kind of figured out here. So I think this is a combination of like two different networks, maybe sentiment analysis and a caption generator. In this case, though, it is able to tell that we have all these people here. We're posing for a camera, which that's kind of cool that it was able to figure that out, and that we're all in a good mood here. And then over here, we have a historical picture of Stalin and Churchill posing for a picture, and that they're real happy, which Churchill's smile here doesn't really scream like super happy to me. And to be fair, if I was standing next to Stalin, I think I probably wouldn't be either. But, I appreciate that it tried. And then, this is style transfer. So this is given one picture that has content and one picture that has a style. Take that style and put it onto the content image. In this case, we have two different styles here. One's this kind of rustly paper sort of thing, and then this one's circuit boards. And we just applied it to this and this deepart.io, so I was able to transfer it over. That we will actually be doing. We'll be making our own version of that at some point. And in fact, here's what will be one of my images I've used for my version of this. Is we have this nice scenic picture of the mountains, and we apply Starry Night to it, and we get this sort of very abstract version of that same picture. And you can look and see that it does in fact represent the content image, but with that new style. And then again, we have that same content image, but we applied this style instead, and it got this real like acid trip sort of thing going on here. So yeah, that was interesting. Another thing we could do is just make blind people see. That's pretty fun. Sort of. It's C with an asterisk, but let's see. Tell me, by the way, if this video ends up being watchable from over Teams, but this is a video of my grandfather who we got him this little camera thing that attaches to his glasses. And
you might need to move the book up a little bit.
Yeah.
And then use your finger.
Scans for it. Yeah, it's kind of hard to hear, but yeah, what that camera is doing is it's taking a picture of the book and of that page specifically, and just reading out what's on the page, and it's fairly good at it. So that's kind of nice. Any questions on that about the different tasks? All right. So we're going to go on to a little bit of the history then. First of all, this field's been around for longer than one would expect. 1957, Frank Rosenblatt created the first model for an ANN. But this was actually a hardware model. This was actually a simple circuit that would model the same behavior that we would use later in perceptrons. But it was a start. It was an interesting kind of idea and a learning circuit. But it didn't have a good learning algorithm attached to it. It was just the structure. Took until 1974 when we were able to actually have a backpropagation algorithm that would help us learn with specifically a 3-layer perceptron, 3-layer neural net. I also have just albums down at the bottom of these time periods. I think in this case it's all in 74 though, because I like that music better. 1986. We also get the release of a general backpropagation algorithm. So this isn't just 3 layers. This will work for any number of layers. And we will be looking at that very algorithm. 1989, Jan LeCun uses the primitive CNNs, convolutional neural nets, to classify handwritten digits. LeCun was definitely one of the people who most kept alive CNNs for a very long time, and eventually they proved to be quite a useful algorithm.
Hey, quick question.
Sorry. Yeah, totally.
You mentioned that perceptrons were originally meant for hardware. Are there hardware-based solutions for image processing then, computer vision?
Yes, there are. That's a great question. We actually have a lecture at some point. I think Sri is going to be doing that on hardware ANNs. That's not going to be for a while, but yeah, it's not as big of a field because it's much more of a pain to actually create a circuit that's emulating these things. But yeah, it's there are hardware neural net solutions in place, and they are understandably much faster than software-based ones. There's actually, strangely enough, light-based neural nets. This is a new thing. They were actually able to take optical fiber. Actually, I don't think it was optical fiber. I think it was actually just lasers or something like that. I'm pretty sure it was a laser neural net, if I remember correctly. I'll have to find that at some point. But yeah, there's hardware solutions, and there's all sorts of other weird ways to implement these things.
Okay.
Yeah. So 2009, ImageNet was created. It's a classification database. And this would kind of set up the revolution in image processing, though it's not quite there yet. This was a really good standard database with lots and lots and lots of different images that would be the goal is object detection. I think I wrote classification here, which isn't quite correct technically, but it's supposed to say the neural network's supposed to be able to figure out what's inside the image. And finally, 2011, this is the hinge year for image processing. This is when Alex Krzyzewski, I think that's it, creates AlexNet, which was revolutionary in this field. It was CNN, convolutional neural net, and it blew away everything else. Specifically, it was in this ImageNet competition, and it was able to get a score way better than anyone else was able to get. And that kind of started this revolution in CNNs. And then since then, we've had VGG nets, which there's been two different main ones, but there's been a couple of them. Google stepped in and made their own that did even better. And then there was one out of academia called ResNet that did extremely well. And all sorts of other specialized nets. This field's kind of fragmented into all these different tasks and networks, and there's just been an explosion in it, which is pretty cool. So, any questions on the history then, before we jump into actual learning some stuff?
Sorry, I'm still focusing on the hardware part. Is it possible that eventually there will be like specialized chips that would be shipping in phones and such that would allow for proper facial recognition? Like, I know there's Windows Hello and facial recognition unlocks for iOS.
I could see that. The thing I would almost expect more would be processors that are made to supplement machine learning, or more possibly even just to run machine learning. So instead of actually doing a lot of the back propagation on the phone, they would send that off to a server, and then the new weights would come into the phone, and then there would be a specialized little chip that would run the forward propagation. But could be. I wouldn't be shocked if one day we had little chips that, like, this is your this is your image processing chip, and it just does object detection for you or something. That could
be. Well, this is Gustavo. The GPUs, the graphical processing units that are used for speeding up graphics for video games or user interface, now they are being used to also compute neural networks, back propagation, forward propagation. So, and yeah, little by little, I think that the GPUs may start shifting from computing just graphics to actually doing neural networks. On the other hand, also there are some boards that NVIDIA produces and Intel produces that actually they are small boards that they have a little GPU for embedded applications that use neural networks. Yeah. Okay.
That's cool. All right.
Yeah.
Thank you guys.
The GPU thing too. We're gonna later in this class. We'll eventually be running some code that's pretty intense to the computer. So hopefully you guys will be using the GPU as well on our different Purdue servers. You don't have to. You can go through the whole class just running it on a laptop. I started with all these labs on my laptop. But if you want it to move a little bit faster, you can definitely make it go a lot faster using GPU. So anyways, though, let's start talking about how we're going to do these labs as far as code works. Well, we have this image processing pipeline. It's important to have a decent structure laid out so that the coursework can follow the same patterns almost. The one we're going to use is not some sort of industry standard. It's just one that I came up with and use a lot. And we will be changing it in certain parts, but this is going to be the general look that all your skeleton code's going to have going in. You're going to have some sort of data you're reading in. You'll be pre-processing that data. You'll be putting that data into a training function, usually just some of the data, usually just the training data. And then you will be using that data to then predict in a test. You'll be doing a run through, and once you have those results, you can evaluate them in several ways. So that's our kind of basic thing we'll be following through every time. And here's what that looks like as a flow chart. We have our raw data, we pre-process it, and then we're going to train a model with our little training data here. We get that model, and then we test it. And we can finally evaluate our final product there. So our first task we're going to look at, simplest possible task probably, is classification. Basic idea here is we have some data and we want to classify it into n groups or classes. We have training data that's already got these class labels attached. One idea for this could be, let's say, cats and dogs. You have 1,000 pictures of cats and 1,000 pictures of dogs, and they're labeled. So you have some little document that's saying, okay, this picture's a dog, this picture's a cat. We are going to have our neural network learn to identify those, and then on some testing data where it's not labeled, we're going to check if it has learned that, if it's able to tell apart a cat from a dog. Classes can be binary or non-binary, being you can have 2 classes, or you can have a bunch of classes, or in very select situations, you can have only one class. That's called one-class classification. Sometimes it's kind of rephrased into a task known as anomaly detection, but that's story for another time. It can be probabilistic or deterministic, basically saying, are we looking for the probability that it's in a class, or are we looking for just it's in this class or not? And furthermore, it can just be, we can represent this as trying to, what did I write there? That was the stocks, yeah. So you could have something like, given an image, whether a stock is going to go up or not, and that the classes in that case would be will go up and won't go up. This isn't a regression. This isn't saying how much it's going to go up, but just a two separate class will or will not. Generally, we'll have this variable y here. Variable y here, and that's going to represent our class label. So in that case, that could be cat or dog in our cat and dog example. And then x, uppercase, is going to be our data. That can be our picture of a dog or picture of a cat or whatever. Generally, the x is going to be called an entry, a tuple, or a record. I usually will say record, but feel free to use any of these. That's often used. And finally, if you're a big probability fan, if you took probability in the past, this is our goal here from a probabilistic standpoint. We want to find or at least for probabilistic classification, we want to find the probability that of some record being in label Y given the data X. So that's kind of what we're doing. And then if we want to go back to that, our processing pipeline, this is what it would look like now. We have our training data, which is going to be training X and training Y. Our testing X is going to go this way. So when we actually run our model, we're only giving it this testing X, but not giving it the Y. And then once we get to evaluation, we can actually look and see how well it did. So about that evaluation, how do we measure how good our neural networks are, how good our, whatever a model might be? We might just have a magical button that we press and it does our job for us. But how do we know how good it's doing? Well, evaluation can be a little bit trickier than is obvious. If you took 373, you'll know this because I think, unless they changed the course again, I'm pretty sure they cover this heavily. But let's talk about accuracy. Consider a problem where we have a binary classification. Maybe it's the loan data, and you have to predict the likelihood whether someone's going to pay their loan back or if they're going to default. We have a model that's going to predict loan paybacks correctly. That's what we're trying to do. So let's run it through accuracy. Let's see how it does on that. In accuracy, we can think of it as being the number of correct predictions divided by the number of predictions total. Or we can dissolve it down even further. Does everyone understand the idea of true positive, true negative, false positive, and false negative? This is a good opportunity for our extra credit, actually. First person to answer, to give me an definition of this can get an extra credit point.
So the true positive is that you predict that it should be true and then it is actually true. And then true negative is you predict it will be false and the actual data is false, so you predict it right. But the false positive is that you predict it right, but it is actually false, and then false negative is you predicted that it will be negative, but it is actually true.
Very good. And just so I can remember the points, what was your name? It doesn't come up on there.
Songhan Lee, or you can just write Han, H-E-O-N.
Nice. Gotcha. All right, good stuff. So yeah, the basic idea here is these two are going to be things that are correct, whether you're predicting positively or negatively in our binary classification. And these two are going to be when you're incorrect, again, whether you're predicting positive or negative. And accuracy doesn't really make a difference between what you're predicting. It's just asking how often are you correct versus how many times did you guess, basically. And there can be some problems with that. So let's take this setup we have here. We have a bunch of records. The true classes are here. This is what their actual classes are with no's and yeses. So we have no, yes, yes, no, yes, yes, yes. We're going to have a model that predicts yes every single time. It's going to be a pretty bad model, but it's going to do is just say yes. Problem is, on this data set we have here, it gets 71% approximately, 5 out of 7. Not a bad score, but that isn't a good thing because we're showing a good score when, in fact, our model isn't very good. And we can't really see why our model's not that good. We just see this score that seems okay. We don't have any predictive power, is what it comes down to. The way to think about that, though, is that accuracy is best. The only time you want to really use accuracy for evaluation is when class labels are uniformly distributed. So you're out of all of your different data that you put in, you have approximately equal number, just uniformly distributed, of every single class. And a lot of times you won't get that, in which case accuracy is not a great way to actually gauge your predictive power. So, other options. Actually, first, does everyone understand that and why we wouldn't want accuracy in certain situations?
Mm-hmm.
Cool. So, here's some other options we have. Precision. This is going to be our proportion of yes answers. So we have true positives over true positives plus false positives, so correct yes answer specifically. You can think of this as how the word is. It's how precise our model is. But we can also do the opposite. We can look for the proportion of real yes answers that were predicted. So out of all the true positives, how many of them were divide that by true positives plus false negatives, and that's recall. So we end up with these two different metrics. One of which is saying how many true yes answers we got and how many true yes answers were predicted and how many we actually got. I'm not explaining that as well as I have in the past. The best way to look at these is actually by the way we have them set up here with the equations. True positives, these are what we predicted as positive and were in fact positive, divided by true positives plus false positives, so all positive answers. And recall being true positives, again, over true positives plus false negatives. And that way to look at it's really nice because then it's easy to calculate. So in our actually, we'll do this first. Forgot the order of these. So even better than those two, than precision and recall, if we just want one number and we don't want to worry about anything else, we can use something called F1 score. And that is the harmonic mean of the precision and the recall. So that's going to be calculated just as taking the precision and recall, multiplying them each, dividing them by the sum of them, and then times 2. So which do we use in any given case? Well, usually if you just need one, just use F1. It'll do the job. But you can still use accuracy sometimes, and you can still use just precision and recall sometimes to figure out in specific areas how your model's doing. And that's the thing. Usually if you're doing evaluation, you can just output all of these and see what comes out. But F1 score is usually our best real look into how well the model's doing. So to predict some of these, we have this new model here. It has done some predictions. We have it predicted this one correctly, these two correctly. It got this one wrong, and it got this one wrong. And you see I've labeled it as such, so we have our true positives, yes, 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 yes. True negatives, no, no. And false positives and false negatives there. And we can use that to calculate that our accuracy is 0.7 in this case, which also just the same as we had before when we had it with all yes predictions. The recall and precision end up being 0.8, and that means the F1 score is 0.8. So this is a genuinely pretty good model, depending on how difficult this would be to be. And loan repayment, this sounds pretty good. So what do we do then in multi-class tasks? In this was a specific case when we had 2 different classes. All we had was yes and no. But what if we have cat and dog and giraffe and lion and everything? Well, in this case, if labels are uniformly distributed, we can still use accuracy, but often they won't be. In which case, we can actually still use F1 score, but it's going to have to be computed a little differently. Specifically, what we're going to want to do in this case is get the precision and recall for each class label, and then take that F1 score and compute it from the average of all those precision and recalls. Or you can even create F1 scores for each specific class label too. And one of the best ways to show this and to do the calculation itself is something called a confusion matrix. Here is one that is actually on one of our first quizzes. In this case, we have up top, we have the truth values. So these are what every record actually is. And we have our predicted values of what our model predicted. In this case, I assume this is pictures of different parts of a city or something where it can be asphalt, concrete, grass, tree, or building. And on a lot of these, what you're really looking for on these confusion matrices is a really strong diagonal here. So we're seeing that out of this 2,397 examples of asphalt, we were able to get 2,385. Same with the concrete, though it seems like a lot of the time with the concrete, it thought it was asphalt or buildings and stuff like that. Oops. But yeah, and you can see because we have these total lines here, that's how we can go about easily computing these precisions and recalls. Because these right here, each of these ones along the spine are true positives. And then each of these are going to be what we use to compute our precision and recall. So I'm going to leave that up to you for the quiz, though, because it's using this exact thing for it. And then I have some links. A few other notes. We're going to do. First of all, let me check the 418. Cool. First of all, this class is based on a class by Andrej Karpathy. He's a very smart guy. He currently, I think Gustavo, does he still work for Tesla as their head of AI?
Yeah, he's the head of the AI, responsible for the automatic driving for Tesla.
Yeah, very smart guy. He did a Stanford class that he put online, and this class is very much based off of that. We also have a few links here on more on evaluation and history. And with that, that's the end of that. We're not quite done with the class because I want to go over a little bit more of the logistics. But do we have any questions on evaluation at the moment?
Is it called a confusion matrix because it shows how often the model was confused?
Yeah, so it's the idea is it's showing not just what the confusion is, but where it is. Because in this, let's say you were to have a lot of examples of tree that ended up being misclassified as concrete, then you can kind of get an idea of why it's doing something badly. You might have to do some extrapolation to figure out what's exactly going on inside, but you can at least know where it's failing.
Okay.
Anything else?
Are there any recommended tools that you would recommend that we get, I suppose, like PyCharm or VS Code or something like that?
So for this class, we're going to be using a lot of Keras and TensorFlow. So those are the big ones you should start worrying about installing. Specifically, we use TensorFlow 2 now. Beyond that, though, not really. I mean, NumPy is important to have. Pandas is important to have. But that's about it. As far as just developing your Python code, I use Atom Editor because I find that the easiest to use. But if you like Sublime or something like that, that's fine. You can use Vim if you want. I don't suggest it, but you can if that's something you'd like to do. But yeah, you can even use an IDE if you want. But again, I don't know that that's the best way to code Python. I usually find that the easiest way for Python is just to use a simple text editor.
Okay. Thank you.
No problem. So with that, let's take a look at our webpage here. So this is where everything that's not on Piazza is going to be here, basically. First of all, let's introduce our TAs. I haven't introduced them yet. First of all, Sri, how you doing? Sri, you still on there?
He left.
Oh, dang it, Sri. Anthony, are you here?
I think campus lost power, Max, so some people may have dropped out.
Oh, did they? That's unfortunate. Yeah, I'm campus watch. Yeah. Wow. All right. Well, Anthony and Sri are good. They've been here. They've been working with us forever. They were actually in our first version of this class way back in, what was it? Spring 2018 or something like that. 29. Yes, spring 2018, I think. So yeah, they've been here a while. The things you're going to want to look at, especially on this site, though, are here's where your lab information is going to be. You can actually see I already uploaded the first homework and the first lab. I wouldn't like its official start date isn't yet, and I probably wouldn't try to get too heavily started on that until after next lecture, because we'll be covering a lot of stuff that's important for that there. But, if you really want to get ahead, then go ahead. We also have here the slides we use. I think I need to replace this with a newer version, but yeah, all the slides, all the videos, including videos from prior semesters. We have these study before lecture things, which try to get to those before each lecture. They will be tested for in the quizzes. We already have the first 2 quizzes out. In fact, this is what they'll be looking like. In this case, there's just 3 questions, 2 of which are to calculate precision recall in different cases, and 1 of which is about history. But yeah, if you sat through this, or if you have the slides in front of you, they shouldn't be trouble at all.
Where's the quiz being turned in at?
So it should. Is it gonna? It won't let me jump through that. There we go. So it'll say at the top of every quiz and every lab and all that where you should turn it in, which in this case is almost always going to be just emailing it to both me and Gustavo. And you'll have the subject neural image processing L1 quiz in this case.
Okay.
And it's all by email, so it shouldn't be a problem. And I'll try to get back to you on those timely, but usually what we end up doing is just kind of making sure everything's graded by the end. If you're behind on something, I'll let you know, but usually you won't be. We've had people get bad grades in this class, but it's not often. It's usually just good grades and better grades, The reasons that we've given people bad grades in the past are like they haven't completed 2 or 3 different labs. So that's the kind of threshold for getting a bad grade. Yeah, if you're finishing the labs and just getting them turned in, even if they're not fully complete, that's fine too. Like that'll.
Okay. Max, yep. Gustavo. I will have to go now. I have to teach now at 4:30. Okay.
Oh, alrighty.
Okay, great. Well, thank you very much. See you next week. If you guys have any problem with the registration, please let me know. I think that it's important that you watch those videos because the classes every week that Max is teaching, they are great. However, there is a lot of material that is, I think that is going to be reinforced and maybe new also in those videos. And Andrej Karpathy also is a very good instructor, okay? Well, yeah. Thank you very much, and see you next week.
See you, Gustavo.
Okay, bye.
So yeah, like Gustavo said, this very good material here, and especially because this is generally his class is for people who've already taken some ML classes, and our class is a bit more on the entry level sort of thing. So a lot of the things he'll cover are going to go beyond what we talk about, which can be very good to just get a look at, even if you don't have to understand it necessarily right away. And I think that's it for right now. Next time we're going to be doing this, we'll be talking about backpropagation. That really we're going to talk about neural networks for the first time in a real way. We're going to go over the theory of how they work, and it should be interesting. We're going to look at it through a couple different lenses and try to understand what's going on, because it's a difficult thing to grasp, but we'll work on it until we all understand it, and then we'll be good to move on. And I think that's it. Don't have anything else. Do we have any other questions on class logistics or?
Yeah. Hey Max, so I can't download the slides
from the link on the course website? Is it possible to like upload PDFs or something?
Wait, it doesn't let you download from. Let's see, because if you do like that,
yeah, I don't
you get to here.
Opens the presentation.
Yeah, you get it through there. I wonder if you can like. That would do is the HTML. Can you print the whole thing? Or... No, it's not going to be smart enough for that. Okay. Yeah, I can do that. I can put some PDFs up there. It probably won't be in this area of it, but I'll throw it down here in the more information or something.
Thanks.
Yeah, no problem. The other thing here is if you want to like kind of see like the final projects and stuff that have been done in the past, all these are good resources. Like we've had some really cool final projects to browse through. We also have a bunch of links here from just interesting links we found along the way, and we'll get to this stuff later. Anything else? Alrighty. I think we should be good then. So the only thing you guys have to do for next week is try to get that lecture quiz done. And that should be it. Well, see you then. Peace.